The bat naturally thrives in moderate Reynolds number flight envelopes where uncrewed aerial systems typically struggle. Demand for these aircraft, such as delivery and reconnaissance drones, has rapidly increased. This has prompted many institutions, including the University of Southampton, to study the bat's membrane wing. All highlight the compliance of the skin tissue as a key part of efficient operation. Taking the analysis further, the bat is also able to manipulate the shape of its wing to provide elegant roll control within flight. This is unlike traditional roll, pitch and yaw control surfaces. However, the age of the bat is over and the time of the human has begun.
Introducing the Vespa, the world's first electroactive membrane-winged aircraft. A platform designed for all future membrane-based flight research, comprised of a rigid wing with a fully modular outboard membrane section. The membrane design encompasses past aerodynamic research, leading to a material choice that mimics the natural counterpart. A pivoting mechanism provides an incidence change, generating a roll moment.
But this moment can also be achieved covering the membrane in a compliant electrode and applying a potential. This creates an electromechanical pressure which deforms the membrane, changing the camber profile as you are witnessing through this archive footage.
One substantial challenge is that the membrane requires kilovolts to deform appreciably, and traditional high voltage sources are not only too heavy, but require mains electricity to operate.
The system had to be miniaturized to achieve the pilot's actuation commands. Voltage converters were identified, procured, and incorporated into the high voltage circuitry.
The primary focus was designing the membrane, so the flight-proven FEEG 2001 fuselage and tailplane was selected and adapted to our requirements. The result is a lightweight aircraft with a proven flight heritage, capable of carrying a scientific payload of 200 grams with a design flight duration of 7.5 minutes. Sustainable materials are used wherever possible, such as FSC and PEFC certified woods.
But unfortunately, due to the COVID-19 restrictions, we were unable to bring our design proposal to life. But don't despair, we produced the digital twin instead. With this, all physical elements of the aircraft have been virtualized and combined into a flight model that not only provides quantitative predictions of the aircraft performance, but also responds to live user inputs via a handheld controller.
To allow a future group to take off where we have left off, a complete assembly manual with a linked bill of materials has been provided. With all this, the Vespa is ready to stretch its wings.